Alright, in this lesson we're going to do various operations on real numbers. We're going to start with adding two real numbers. First of all, we start with the same signs. Whenever it's the same signs, you combine. Whenever they're opposite signs, you subtract. Okay, so same signs combine, opposites subtract. So if I see negative 12 plus parentheses negative 8, we're saying I have negative 12, I owe 12 already, and I'm getting more negative, which means I owe more, another 8. So I combine them, and I should get 20. Now it's a negative 20. Okay. Now, usually when we combine, we think about keeping the value of the bigger one, but it's more important with opposites. Here, we both are negative, so the answer is also negative 20. Okay. So now, we're going to take a look at negative 6 plus negative 3. Again, these are the same signs, so you combine them to be negative 9. Okay? So this continues with decimals, like negative 1.2 plus negative 0.4. They're same signs, so you combine them. And so the nice thing about these decimals here, first of all, we should stack them and get 0.4 like this, and it's negative. But if you struggled with decimals before or fractions before, you have a calculator. And I fully expect you, this being an online class and I'm not hovering over your shoulder, you should be using a calculator. But here we can stack and add to get 6, bring down the decimal, and I get negative 1.6. Okay. And then we have another problem to add. Got negative 5/6 plus negative 1/3. And if I combine these, I have to have common denominators. Again, you could do it in your calculator. Or make common denominators by multiplying top and bottom of the second one by 2. So that it's really negative 5/6 plus negative 2/6. And when you have common denominators, you just add the tops. So this is going to be 7/6, negative 7/6. And yes, it's an improper fraction, and that's okay. You don't need a mixed number. Okay, so now we're going to add numbers that are opposites. So something like negative 17 and positive 11. Now they're opposite signs, so you need to subtract. Opposites subtract. So what we do is we stack them and subtract them. So it's really 17, ignore this negative sign, minus 11. Now the bigger number always goes on top, so that's why 17 on top. And we go ahead and subtract, and we get 6. Now the value at the end is always coming from the bigger number. The value that was the top one, that's here in this case it's negative, means my answer is going to be negative. That's because I had negative 17, I owed 17. It's like I paid off 11 that I had, and I still owe somebody 6. Okay? So let me recap that. You keep the bigger number on top, put the smaller number on the bottom, and because they're opposites, you subtract, and you keep the value of the bigger one. So the answer is negative. Alright, so let's try another one. Here we've got 4 plus negative 1. They're opposites, so I stack it. The bigger one's 4. The bigger value is 4. So I put 1 on the bottom, and I subtract and get 3. Now, 4 was the bigger one. It was positive, so my answer is positive 3. Okay, let's try another one. Okay, I've got negative 9, positive 17. The 17 is larger, so I'm going to put it on top and put this 9 underneath. And so they're opposites, so I subtract them. And if I subtract here, I'm going to get 8. And the value of the 17 was positive, so my answer is positive. So let's try one with fractions. This one has negative 4/5 plus 2/3, and they're opposite signs, and they don't have common denominators. So I need to multiply this one by a 3, and this one by a 5. And that's going to give me negative 12/15 plus 10/15. Now the 12 is the larger value, and so what I do is actually subtract the 12 minus 10, and that's going to give me 2/15. Leave the bottoms alone. But because the 12 had the larger value, you put the negative here. Now when I say larger value, I mean larger absolute value. 12 is bigger than 10 if you weren't worried about the sign. I know technically 10 should be smaller, or should be larger than 12, because 12 is negative, but we're talking about the value there. Okay, so that's how you add real numbers. Now when we subtract real numbers, we're really supposed to be worried about this one. We're going to have to minus a negative. But if I had something like 6 minus 4, the book wants you to rewrite this to be 6 plus negative 4. Now I think that's ridiculous, because I think we know how to do 6 minus 4 and come up with 2. So I ignore this step, and I'm not going to worry about that again, but I will show you the changing the signs when you have a negative. So for example, you could have 6 minus negative 4, like that. Now whenever you have two negative signs next to each other, what you want to do is change both the signs. I call it change. You change twice. Okay, and what happens is you're minusing a negative, so it actually turns to plus a positive. So it turns into 6 plus 4, which is 10. Okay, so whenever you're minusing a negative, you change, plus a positive. Okay, minus a negative turns into plus a positive. So let's look at one more example. So let's look at negative 12 minus negative 7. Now, the negative in front doesn't change anything, but these two negatives need to be turned to positives. Whenever there's two negatives next to each other, they turn positive. So this is really negative 12 plus 7. Now we got to go back to our last slide, which was saying that now they're opposites, and opposites really subtract. You put the 7 underneath the 12, subtract, and you get 5. Now because the 12 had a larger value, and it was negative, the answer has to be negative. So that's how I work out that particular problem, negative 5. Now sometimes we're going to see a problem like this one, negative 12 minus 5. Now, because they're both negative, because the 12 is negative and this one's negative, even though there's not a plus sign, they're both negative, so you actually combine, even though it says 12 minus 5. This is the only time where it actually comes in handy to say negative 12 plus negative 5. In other words, you had negative 12 and you're getting more negative, which means that your answer is going to be negative 17. Okay, so again, the book is going to want you to say, alright, plus a negative, in other words, change the sign, but you don't have to if you can see that they're both negative to begin with. And of course, this process also works with fractions. So you can see these are both negative, so I'm going to change. So now I just turned it to a plus problem. And I need to make common denominator, it's going to be 24, so I'm going to multiply the 6 times 4 and the 8 times 3. And that's going to give me 20 over 24 plus 9 over 24. And then I just add the tops, and I get 29 over 24. Now you're going to get some problems that say find the difference between the distance between points on the number line, and they're going to say something like 8 and negative 4. Basically what they're wanting to do is really find the absolute value of the difference of the numbers. So what that looks like is you really take the absolute value of 8 minus negative 4. Okay, so that's actually what the process is. You need to add a little subtraction sign between, so instead of and, you write a minus sign, and then take the absolute value of it. So here we just change the signs, and that's really 8 plus 4, which is 12. The absolute value of that is just 12. Okay, so another one would be like negative 4 and negative 6. So again, you just write negative 4 minus negative 6, and take the absolute value of that. So in this case, again, the negatives change to positive. So this is positive 6, negative 4. So you actually subtract, and it'll be 6 minus 4, which is 2. So it turns into an absolute value of 2, and the answer is 2. Okay? So that's the extent of those problems. So now we're going to take a look at multiplying real numbers. And there's two types. There's multiplying with same signs, and there's multiplying with opposites. Well, same signs, the answer will always be positive. If they're opposites, the answer will always be negative. So that's hopefully an easy way to remember. So now let's take a look at some examples. So, like if I had negative 3 times negative 9, I multiply them. Whenever they're squished together, by the way, that means there's multiplication happening between them. So I multiply 9 times 7, which is 27. 9 times 3, I jumped to the answer there. 9 times 3 is 27. And because they're both the same sign, the answer is going to be positive 27. You don't have to write the plus sign, I'm just putting it there to highlight it. Okay, so let's take a look at something like negative 4 times 5. Now because the 5 is positive and the 4 is negative, these are opposites, so the answer is going to be negative, and then I multiply 4 times 5, which is just 20. So now I'm going to show an example of multiplying with decimals. And if you multiply decimals, first of all, the answer is going to be positive because these are both negative. But when you multiply decimals, you want to stack them. So I would do 0.5 or times 0.4. And it doesn't matter which one's on top. And you go ahead and multiply the 4 times the 5, which gives you 20. You could multiply the 4 times the 5 and then the 4 times the 0, but it doesn't matter. So we get 20 there. And then you just count how many decimal places you have. So because there's a decimal place here and decimal place here, you count over 1, 2 places, and the answer is 0.2. And it's positive 0.2 because it was negative times negative. So now let's see another multiplication problem. I've got negative 1.4 times 0.2. So if I was to multiply the 2, I'd multiply it and get the 8, multiply and get 2, and then this time again I have 2 decimal places, and so I move the decimal over 1, 2 places. But this time the top one was negative, the bottom one was positive, so the answer is going to be a negative 0.28. Okay? So now we're going to take a look at multiplying fractions, and these ones are, first of all, they're both negative, so the answer is going to be positive. But whenever you multiply fractions, all you have to do is you multiply the tops. So I multiply 3 times the 5, which gives me 15, and then you multiply the 4 times the 6, which gives you 24. Now, I always say multiply straight across because you don't cross multiply, which a lot of students do on accident. Multiply straight across, 3 times 5 to get the 15, and multiply 4 times the 6 straight across to get the 24. Now we need to talk about something called reciprocal. Reciprocals are when you have something like 5/8. The reciprocal of 5/8 would be to flip that over and get 8 over 5. Now, if it was something like negative 2/3, you still flip it over and get negative 3/2. Notice that the fraction stayed negative. It doesn't change. Now, it's not the opposite where you do that's called the negative reciprocal, where you actually take the negative sign off. So reciprocals mean you just take and flip it over. You'll have some questions that ask, what's the reciprocal? So you just take whatever the fraction is and flip it over. Now, what if it's not a fraction, like 20? Well, 20 actually is a fraction. 20, or anything, is actually over a 1. So the reciprocal of a whole number is 1 on top of whatever that original whole number was. So this fraction, or this reciprocal, is 1 over 20. So that's helpful when we're doing division, or finding a quotient. For example, sometimes I have to divide by a fraction. For if I have like 2, and I want to divide it by 1/3, I do what's called flip and multiply. And at least that's what I call it. It's flip and multiply. What you're supposed to do is take whatever you're dividing by and flip it up to the top. In other words, you leave the number on top, the 2, and you times it by, flip and multiply by 3 over 1. So the answer here is really 6. So it's 2, the 2 is really over 1, you multiply straight across, and you get 6. The 1's don't matter on the bottom. So that's why reciprocals are helpful. It helps us with division. Now let's talk about how positive and negatives play. If I have something like negative 12 divided by 4, well, it's just regular division, 12 divided by 4, which is 3. But because the top one was negative, that means our answer has to be negative. So division has the same rules as multiplication. If they're the same signs, if you're multiplying the same signs, the answer is positive. If they're opposite signs, the answer is negative, like this case. Okay, so division has the same rules as multiplication. Okay, so if I had a problem where it was negative 20 divided by negative 5, because they're both negative, they cancel out, the negative signs cancel out, and it turns to a positive 20 divided by 5, which is just 4. Okay. Now let's take a look at a fraction problem, like negative 2/3 divided by negative 5/9. Okay. Now this is a fraction divided by a fraction, and whenever you have a fraction divided by a fraction, or whenever you're just straight dividing by a fraction, you need to flip and multiply. So I rewrite it to be negative 2/3 times the flipped fraction, the reciprocal, 9 over 5, still negative. And then, now that I've flipped it over and made it a fraction times a fraction, you multiply straight across. Negative 2 times negative 9 is positive 18, and 3 times 5 is 15. So the answer here is, oops, sorry, not 18, 15. The answer here is 18 over 15. So let's try one more problem where we've got division of fractions written a little bit differently. If it was like this, negative 9 over 14, and then they write divided by this way, 3 over 7. It's not the way that I had it before, but still it's dividing by a fraction, so I take the second fraction and flip it over and multiply. Flip and multiply. So whenever you're dividing by a fraction, you flip and multiply. So it's negative 9 over 14, and you flip and multiply by 7 over 3. And once you do that, you just multiply straight across. Okay, so once you've got it flipped, then it's just a process of multiplying straight across. Negative 9 times positive 7, you get 63, and it's negative because the 9 was negative. And then you do 14 times 3, which gives you 42, and that will be sufficient for our answer.